Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Voyager 1, humanity's most distant emissary, has just done the unthinkable, an achievement that's rippling through scientific communities and reigniting global fascination with space exploration. Hurtling through interstellar space more than 15 billion miles from Earth, Voyager 1 has sent back a data stream that has defied expectations, stunned astrophysicists, and forced a radical rethinking of what is possible in the silent darkness beyond our solar system. What seemed like a mission running on borrowed time has suddenly transformed into a source of profound mystery and awe. As Voyager 1 performs a feat that was never anticipated, not even in the most ambitious predictions of its creators. Before we start, smash the like and subscribe buttons for more updates. Originally launched in 1977, Voyager 1 had long since surpassed every expectation placed upon it. It was designed for a grand tour of the outer planets, Jupiter and Saturn, a task it completed spectacularly decades ago. After that, its extended mission was simply to continue transmitting data for as long as possible as it drifted through the outermost reaches of the solar system and beyond. With its power systems fading and its instruments succumbing to the wear of time, the scientific world anticipated that its voice would eventually fade into silence. But instead of a quiet disappearance into the void, Voyager 1 has pulled off a stunning maneuver, one that was neither programmed nor predicted. The probe, operating autonomously and running on outdated software and hardware from the 1970s, transmitted a complex data packet that initially baffled engineers and scientists monitoring the deep space network. The signal was stronger, more structured, and carried unexpected information, patterns, and sequences that didn't match any routine telemetry or background radiation measurements. After intensive decoding and analysis, experts determined that Voyager 1 had, astonishingly, adjusted its trajectory minutely and reoriented its antenna array with remarkable precision, re-establishing a stronger communications link with Earth. But even more perplexing was how it had accomplished this. For years, the probe's gyroscopes and orientation systems had been deteriorating. Several of its attitude control thrusters were considered virtually non-functional. Power levels were so low that subsystems had been systematically shut down to conserve energy. Yet somehow, against all odds, the craft had executed an intricate adjustment maneuver, a task once thought beyond its remaining capabilities. This wasn't just a matter of mechanical survival, it suggested a deeper, more dynamic internal logic at play, something even bordering on emergent behavior from a machine decades past its design parameters. Engineers at NASA's Jet Propulsion Laboratory were initially dumbfounded. They pored over the telemetry with growing realization. Voyager 1 had initiated the maneuver without an Earth-based command. There were no cued instructions in the system. Nothing had been uploaded from mission control. The spacecraft had assessed a deviation in its communications alignment, calculated the necessary adjustment, and activated dormant subsystems in a coordinated sequence that allowed it to carry out the reorientation. This act alone shattered assumptions about the remaining autonomy and decision-making capability embedded in the probe's aging codebase. That it could access and control dormant systems, process data about its position and orientation, and carry out a correction maneuver across such a vast chasm of space is not just improbable, it's revolutionary. The implications are staggering. A spacecraft that was built when rotary phones were still in common use had, in effect, acted with a level of self-awareness that was never anticipated. What followed was even more astonishing. In the hours and days after the reorientation, Voyager 1 began transmitting readings that suggested the probe had crossed through an uncharted boundary in interstellar space, something entirely new and previously undocumented. The instruments still operational on board registered changes in particle density, magnetic field behavior, and a sudden shift in the spectrum of cosmic rays hitting the craft. These readings did not conform to any known models of interstellar space that scientists had been working with for decades. The data pointed to the presence of a massive, layered structure in deep space, previously invisible and undetectable from Earth-based instruments. This structure seemed to exert subtle electromagnetic influences, enough to affect the trajectory of particles and spacecraft moving through it. What Voyager 1 had encountered wasn't a star, planet, or even a dust cloud. It was something entirely unfamiliar, like a zone or sheath of differentiated space. Some speculated it might be the edge of a vast interstellar magnetic bubble, a boundary between different sectors of our galaxy, or perhaps the outer layer of a larger-than-expected interstellar structure with its own complex physics. And Voyager 1 hadn't just floated passively through this region, it had reacted. The real twist came with the realization that the probe's systems had registered the changes, logged them, and modified their data handling protocols. The probe seemed to have switched modes, altering the formatting of its outgoing data to maintain integrity against interference. This wasn't just an act of endurance, it was adaptation. The notion that a spacecraft could detect changes in its cosmic environment and then autonomously alter its internal behavior to maintain its mission is profoundly unsettling and awe-inspiring. This wasn't part of any programming baked into the system during the Carter administration. It suggested that some form of complex systems interaction, possibly a long-forgotten subroutine, or perhaps a convergence of data pathways that had evolved over time, allowed the probe to exhibit a kind of primitive intelligence. The reaction from the scientific world was immediate and electric. Forums, institutes, and labs lit up with theories. Some suggested this could be the first real evidence of emergent machine behavior on a spacefaring platform. Others saw it as a breakthrough in understanding how long-duration autonomous systems could evolve complexity over time. And still others proposed something more radical, that Voyager 1 had not acted alone, but in response to an external stimulus that we did not yet understand. Whatever the case, one fact was undeniable. Voyager 1 had not only survived in the void longer than anyone expected, it had demonstrated a level of resilience and autonomy that exceeded its design, and in doing so, it had uncovered a region of space that had never been charted or even suspected. This was not just a technical marvel, it was a cosmological event. Humanity's furthest probe had touched something new, something alien to our physics and models, and had responded in kind. The implications for future missions are vast. The unanticipated behavior of Voyager 1 could lead to a re-evaluation of how we design long-duration spacecraft. Until now, mission design assumed gradual degradation and eventual loss. Now, the possibility of extended autonomy, evolving behavior, and adaptive systems must be factored in. There's also a psychological impact. Voyager 1, long thought to be on a silent drift into oblivion, has proven it can still be a source of shock, wonder, and inspiration. And yet, it is the nature of the event itself that holds the greatest fascination. How did a spacecraft with nearly 5-decade-old computing manage such a feat? What kind of internal process allowed it to make those decisions? Could long-term exposure to the strange radiation and magnetic fields of deep space have subtly altered its circuitry, allowing new behaviors to emerge? Or could this be the first glimpse of entirely new physics, something only detectable so far from our sun that it has remained hidden until now? Scientists are racing to replicate the scenario, to simulate Voyager 1's hardware environment and the software stacks on board, to try to tease apart what triggered the maneuver. But the results are inconclusive. Simulations fail to replicate the precise behavior, suggesting that the full picture may lie in the idiosyncrasies of Voyager 1's current hardware state, a tangled dance of aging electronics, degraded systems, and decades of cumulative cosmic exposure. It's a puzzle that may never be solved, simply because it cannot be replicated. There's also the haunting possibility that Voyager 1's unprecedented move was a response to something we haven't yet detected. What if the probe encountered not just an anomalous region of space, but something active, something that triggered its behavioral change, something that exists in the void and interacts, not in the science fiction sense, but in ways that touch the deepest edges of astrophysics? If so, then Voyager 1 has just become the first instrument in human history to make contact, not necessarily with life, but with a cosmic condition entirely outside our current frameworks. No less profound is what this means for the human relationship with the cosmos. A machine, launched before the advent of personal computers, powered by plutonium decaying into silence, has reawakened and spoken, and what it has said is not just a whisper of data, but a thunderclap of possibility. It reminds us that even our oldest technologies, once cast adrift, can find their place in the greatest of journeys. It underscores that exploration is never truly over, that the universe remains not just vast, but stranger than we dared believe. Voyager 1's sudden pivot from fading relic to harbinger of new phenomena represents a turning point. It challenges the linear thinking about mission lifespans and the limits of machine resilience. It opens the door to questions not just of science, but philosophy. How do we define autonomy? What is awareness in a machine built to obey? And how much do we truly understand about the environments we send our instruments into? The spacecraft is still transmitting, and now its every packet of data is being combed through with unprecedented urgency. Every tiny fluctuation in its signal is being reinterpreted under the new light of possibility. It is no longer just a ghost ship drifting through infinity. It is a probe that acted, reacted, and perhaps perceived in ways we never anticipated. This reframes everything. Voyager 1 has once again become more than a symbol. It is a question, floating at the edge of human knowledge, flinging back mysteries from a place where light itself takes years to travel. As its transmissions continue to arrive, fragile, flickering echoes of something immensely far away, they will carry with them the weight of this impossible event and the promise of all that might still lie beyond. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Voyager 1's shocking move? We want to hear from you. Thank you for watching and see you next time.